Thank you for joining us this afternoon, as you can see, to celebrate the establishment of the Weidenthal Family Professorship in Career Development and Philippou as the inaugural chairholder. And I want to congratulate both families for joining us this afternoon and helping us to celebrate. There are few more exciting things for a dean to do than to bestow a professorship on an active and productive faculty member, and we get to do so this evening. Very often we acknowledge our senior faculty, but there are situations as this one where specifically we want to make sure that we recognize our up-and-coming stars, encourage them with support and assurance of ongoing opportunities that they will have to develop their careers here at the Case Western Reserve School of Medicine. Now, endowed professorships are broad-ranging and, as endowed, long-lasting. I'll remind you that early in the Renaissance, the first endowed professorship was established by King Henry VIII, I'm told, or read, in 1540, a few years ago, who founded the Regius Chair of Civil Law at Oxford University. That's been held by many. The oldest in the U.S. Was established in 1721, the Hollis Professorship of Mathematics and Natural Philosophy in 1721, when Harvard, for the most part, was a Protestant school. And the professorship meandered its way over from the Divinity School to the Department of Physics, back to Divinity School. It's now held by a woman, Karen King. I'm not sure that Dr. Hollis would have imagined a woman holding that chair back in that time, but we're glad that that has happened. The oldest chair at Case in the School of Medicine is Leonard C. Hanna Professorship, established in 1901, a gift of the Howard Hanna family. Next came, in 1903, a professorship in anatomy established by Henry Wilson Payne, and the Hanna Payne Professorship came right thereafter as a joint family professorship in 1906. So all of those have gone on to be incredibly supportive elements for our school and be held by very prominent and long-lasting physicians and scientists and professors and chairs of departments. There are over now 125, and we're obviously able to do so because of the incredible generous donations and support of our alumni and friends who've done a lot for our community and help us out in many, many ways. In general, they help support the school's overall mission, which is to improve global health by linking research to populations in a superb educational environment. And within that one sentence, we cover research, we cover populations, we cover health, we cover global health, so that our range and impact is huge and broad. And today, the Faculty of Medicine is at 5 campuses in the city of Cleveland, at 4 of our hospitals, as well as here with 3,400 full-time faculty and another 4,000 part-time faculty contributing to our education program. So we're pretty far-ranging. And each professorship helps us broaden and stabilize that effort. Let me tell you about the Weidenthal Family Professorship in Career Development. Dan moved to Cleveland with his family in 1932, I believe. His father was a pediatrician at Mount Sinai and St. Luke's Hospital. Dan followed in his father's footsteps, became a physician, was admitted by Jack Coy to the medical school in 1954, completed his residency in ophthalmology in Detroit, took a special interest in retinal diseases well before we understood those processes. Went on to the Armed Forces Institute of Pathology at the Walter Reed campus to do some research and further his training, and then went on to Mass Eye and Ear and the Retinal Research Institute. There he really learned from the world's expert in retinal diseases. In 1965, he then returned to Cleveland and set up shop as the director of the residency program at St. Luke's Hospital, and then relocated to the Landmark Center on Science Park Drive in Beechwood in practice. He's been very, very active on our alumni board, serving as past president and current member. He's been a member of our Brain Health Council, which has been important in the Department of Neurology. And in 1997, he received the Medical Alumni Board's Cliff J. Voigt Service Award. So it's not surprising that with that support of the school, that he caught the eye of prior Dean Pam Davis, and with a little bit of jiggling of encouragement on her part. By the way, it's Dr. Davis's birthday today, so happy birthday. He then began the Tillis Weidenthal Professorship in Neurology after his wife Judy, an accomplished Cleveland photographer, had developed Parkinson's disease. And so we now have a second professorship to advance the careers, as I've said, in neurologic diseases and disorders, and to encourage younger members of our faculty. So with that introduction, I want to thank Dr. Weidenthal for his incredible support and family support, and ask him to come on up and give us a few words. As you enter the stage, I will show off this bowl we'd like you to receive. I'm going to let it stay here so you don't
Yeah, because we don't want two bowls.
Exactly.
Yeah.
The Weidenthal Family Professorship in Career Development, and believe it or not, we're celebrating it today, July 20th, 2023. During COVID, we were off by a couple of years. So.
Okay, great.
All right.
Listen, thanks. You know, what you said, I knew a guy just like that. But you know, I think everybody here would rather be working or hitting golf balls, but here we are, so let's make the most of it, and that's what I'm going to try to do by being brief. I do want to thank my boys, Jeffrey Weidenthal, who's graduate of the law school, and Dr. David Weidenthal, who's on the faculty of the School of Dental Medicine. And some of the fun of having some money is really giving it away, because and my son Jeffrey, who has been instrumental in helping this accumulate, I think it's as big a kick out of it as I do. The search committee, I think, did a wonderful job, and I saw a picture of our recipient, Paula Philippidou, and I thought the only way to get to know her would be come up with this professorship, because otherwise they'd think it was stalking. So anyway, that's what I did, and I couldn't be happier. I think we've got a marvelous recipient, and I'm really anxious to hear what she has to say and don't want to get in the way. And I want to thank Dean, and I want to thank everyone involved in helping us put this together. And I'll tell you, when I had lunch with Pam Davis, and she said, well, here's what I want you to do. She knew I'd do it. And so, you know, when she said jump, I said, how high? And it was pretty high. But so anyway, the first professorship was in memory of my wife, Judy. She was helped here by, she had a high amplitude tremor. She had Parkinson's disease. And neurosurgeon helped her a great deal. I can't remember Jonathan's last name, but he was marvelous. This was pretty easy early in the, the deep brain stimulation. So you had to take it on faith a little bit. And, if you didn't hit exactly the right nucleus, a lot of other things could happen. But my wife was helped a great deal by the neurosurgeons here. So I think I've said what I have to say. And one thing I note that Paula is a marathon runner. I think running is very good for your brain. And the level at which she's operating, she's got, I think, more synapses than the rest of us, because when I was trying to get this, the transmission was a little slow. So I finally got it when I got home an hour later, but that's my trouble. Anyway, I hope you all enjoy it. I certainly enjoyed creating this.
We couldn't do it without you and with the family, so thank you greatly. Now, I don't get to introduce Paula further than you've heard so far, but I do get to introduce her boss, Evan Daenerys. Dr. Daenerys is the interim chair of the Department of Neurosciences, directs our mouse behavior phenotyping core. And let me tell you a little bit about Dr. Daenerys. He earned his BS in chemistry at San Diego State, his PhD at UCLA, completed his postdoc at the Salk Institute, where he became interested in neuronal nicotine receptors in the brain, and then went on to discover several subunits using molecular cloning technologies. His current interest is in serotonin neurotransmitter systems, which is incredibly important in early development, most neurologic functions, and neuropsychiatric disorders, which we're still trying to understand better, as well as safeguards to neurodegeneration. And dysregulation is a major factor in this pathway of many neurologic disorders. So he's undertaken a variety of studies, both looking at genetic mechanisms that act across the development path and lifespan of organisms in the regulation of these serotonin receptor systems, and how modulations of them impact disease. And he's made a few important observations around the role of PET1 in autism and intellectual disability. And we will be celebrating the inaugural chair he will hold from the Seibel family Professorship in Neurodegenerative Research, and we'll be celebrating that this fall. So without further ado, I'd like to introduce Dr. Daenerys.
Thank you very much, Dan. And nice to meet you, Dr. Weidenthal. I'd also like to verify that despite these atypical clothes, I am Evan Daenerys. It's truly a pleasure to introduce Dr. Weidenthal-Philippidou today. I believe Dr. Philippidou richly deserves the Weidenthal Family Professorship in Career Development for her many accomplishments in research and teaching over the years as a junior faculty member in our department. She arrived in our department in 2016, and since that time, she has built a robust NIH-funded research program, while at the same time having a major commitment to training the next generation of neuroscientists. And so she began her education with a BS degree in biochemistry, summa cum laude, at Stony Brook University. And then she stayed at Stony Brook and earned a PhD in neurobiology and behavior. And the focus of her thesis research for her PhD was to identify the specialized endosomal complexes that enable track receptor retrograde signaling in sympathetic neurons. And after that, she went on to the HHMI lab at NYU run by Jeremy Dazen, where she developed her interest in respiratory circuitry. So as a CWRU member over the past few years, she has become an exemplary contributor to education and service. She serves on a number of committees already. She served for 6 years as the neuroscience representative to the Biomedical Research Training Program Admissions Committee, which is super important for all of us. She did a great job at doing that and evaluating students and recruiting the top students for us. She's also serving as a member of the Medical Scientist Training Program Steering Committee, and she is also a member of our Inside Departmental Graduate Education Committee. So she makes lots of contributions to the mission of our program at the level of research and education. Not only that, during this brief time that she's been here, she has become an exceptional mentor to graduate students. And that's been amply evidenced by her being the recipient of a very prestigious and competitive award called the John S. Dykoff Award for Distinguished Graduate Student Mentorship. She earned that in just last year in 2022. And on top of that, her students have been really super successful at securing individual predoctoral fellowships for the research in the lab. So those are all marvelous achievements in a very short time. So to talk about a little bit about her research program, you know, I think her research is focused on a topic that we can all instantly appreciate. And that is, how is our ability to breathe at the moment of our birth ready to go so that we don't die? It's got to be ready to go as soon as we're born. And up until Paula's research, there was hardly anything known about this, surprisingly, for such a fundamental, crucial developmental process for life. And so what Dr. Philippidou's research has elucidated over the last several years with her graduate students are the regulatory factors, the transcription factors that in this case are called Hox proteins that are crucially, essentially involved in building the neural circuits that enable us to breathe for the rest of our lives. And so Dr. Philippidou has published several papers on this topic over the last few years as a principal investigator at CASE. And these papers are a testament to her research excellence because they are comprehensive and they are filled with compelling and impressive data. And I encourage you to take a look at some of them to verify what I just said. Actually, two of her papers were selected by these top journals for special previews by the editors of the journals, which doesn't happen very often. Finally, her work is gaining substantial recognition through the many invited seminars, lectures she's been given over the past few years, particularly the 6 or 7 that she has given over the last 2 years at places like the Max Delbruck Center for Molecular Medicine in Berlin, Columbia University, Johns Hopkins University, Genelia, Cold Spring Harbor, Chicago, University of Chicago, and a talk in St. Andrews, Scotland on motor neuron development and function. So really major accomplishments. And so Dr. Philippidou, Paula, I just want to say congratulations on your appointment as the inaugural chairholder of the Weidenthal Family Professorship in Career Development. It's all yours.
All right. Thank you, Evan, for that really nice introduction. I'm incredibly honored to be here. And as Evan mentioned, my lab is interested in the development, assembly, and maintenance of the neural circuits that control breathing. So how did I become interested in research and breathing specifically, and what led me to start my lab here at Case Western? Well, it all started in a small island in the Mediterranean, Cyprus, where I was born and raised. And so even though Cyprus is only about 1/11 the size of Ohio, it nevertheless has abundant natural beauty. So much so that according to Greek mythology, it's considered to be the birthplace of the Greek goddess of beauty and love, Aphrodite, who was thought to emerge by the water right here by these rocks. And as a child, I took full advantage of living on such a beautiful island. Around this time, I also started becoming interested in the natural world. I became very attached to my stuffed monkey, who, to my mom's great dismay, I started calling grandmother. When I found out about the cloning of Dolly the sheep as a teenager, I decided that I had to become a scientist, having only a very vague idea about what scientists do. And this would have most likely had remained a dream had it not been for cultural exchange programs between the United States and Cyprus. And so probably one of the most critical turning points in my life was when I received a letter informing me that I had won a Fulbright scholarship to attend university in the United States. And this letter turned out to be prophetic, as this was, in fact, the beginning of a very rewarding and exciting experience for me. And so the first decision I had to make was where to go to university. And I decided to move from one island to another and get my bachelor's in biochemistry at Stony Brook University in Long Island, New York. And this was partly so I could keep honing my boating skills, but also because of Stony Brook's strong reputation as a public research university. And as an undergraduate, I began conducting research with Dr. Harvard Lyman on the phototaxis of algae. And I became completely fascinated with the single-cell organisms that would just begin migrating towards the light as soon as they were exposed to it. This very rudimentary behavior also piqued my interest in the brain. And after taking a few neurosciences courses as an undergrad, I decided that this is what I wanted to do next. And so I decided to stay at Stony Brook and pursue my PhD in neurobiology in the lab of Dr. Simon Halekua, who studied neurotrophin signaling over time and space. So neurotrophins are a family of growth factors that mediate neuronal survival, development, and function. And a major question in the field at the time was trying to understand how neurotrophin signals that are initiated at the nerve terminal are relayed back to the cell body of the neuron that can sometimes be more than 2 meters away. And so in Simon's lab, we were able to define and characterize a specialized endosomal population that was resistant to degradation and that would mediate retrograde trafficking of neurotrophins and their receptors back to the cell body. Really defining novel mechanisms of how neurotrophins can signal over time and space. Another major milestone in my graduate career was winning the Stony Brook softball championship after many years of trying. As you can imagine, this was not an easy feat for a team called the Action Potentials. Towards the end of my PhD, I became very interested in understanding how different classes of neurons are specified. And so I moved to the lab of Jeremy Dason at NYU School of Medicine for my postdoctoral work to address this question in vivo. And in the Dason lab, we took advantage of mouse genetic tools to understand how a specific population of motor neurons, phrenic motor neurons that innervate the diaphragm and are critical for breathing, are specified during development. And in the Dason lab, I was able to identify a set of transcription factors, HOX5 proteins that mediate the development of phrenic motor neurons and show that when you remove HOX5 genes from mice, they die at birth due to respiratory failure. During my time in the Dason lab, I also decided to take up running. And I thought it was a good idea to subject myself to running 26.2 miles in the streets of New York City. And so this endeavor, along with my work in the Dason lab, really convinced me that breathing is a very important behavior. And so when I started my lab at Case Western in 2016, we really focused on understanding how these circuits develop and how they're maintained. And so each one of us takes about 700 breaths every hour. And we do this without ever having to think about it. However, despite appearing so deceptively simple, breathing really relies on very complex circuits within the brainstem and spinal cord to generate a robust yet flexible behavior. And when these circuits don't form correctly, the impact on the behavior can be immediately apparent. And unfortunately, we can see this in many developmental and genetic disorders, such as Rett syndrome, sudden infant death syndrome, and Down syndrome. Of course, our lab was not the first to be fascinated by breathing circuits. In his treatise on breath, Aristotle asked, "Tisi tu amphidu pneumatos diamoni, και tisi αυξήσεις," which roughly translates to, what is the mode of growth and the mode of maintenance of the natural breath? And so more than 2,000 years later, we still don't have a complete answer to Aristotle's question. However, we have made a lot of progress. For example, we know that the circuits are localized within the brainstem and spinal cord. And of course, we know that the final output of these circuits is the contraction of muscles in the periphery, such as the diaphragm muscle, which is the major muscle involved in respiration in humans. And so for the first 5 years, my lab has tried to address really fundamental questions about this circuit. In a series of studies, we showed how different neurons within this circuit are specified, how they find and connect to each other during development, and also how these circuits respond to different environmental challenges, for example, high levels of carbon dioxide. And about a couple of years ago, we also started becoming very interested in this question of how are these circuits maintained in adulthood, and how could they possibly break down in neurodegenerative diseases. And this was around the time that I received the wonderful news from the provost and the board of trustees that I was appointed to the Weidenthal family designated professorship in career development. And so because of this very generous gift, we were able to recruit a new talented graduate student in the lab, Raquel, who began working on trying to identify mechanisms of respiratory dysfunction in diseases such as amyotrophic lateral sclerosis or ALS. And so most ALS patients die within 3 to 5 years of diagnosis because of respiratory failure. And so it's really imperative that we try to treat these breathing symptoms in these patients. This gift also allowed us to forge novel collaborations, including with Dr. Andrew Pieber to study respiratory dysfunction in Alzheimer's disease. And we have very exciting new data showing that there is a significant increase of apneas that even precedes cognitive decline in a mouse model of Alzheimer's disease. And so because of Dr. Weidenthal's generosity, we're able to continue studying breathing dysfunction in different neurodegenerative diseases, trying to identify novel therapeutic targets and contribute to the development of novel treatments in the next few years. And so needless to say, I'm incredibly grateful to be in this position and would like to thank some of the people that have made this possible. And so I would really like to thank Dean Gerson for supporting our research and giving my lab and I this great opportunity. Dr. Evan Daenerys, Chair of Neurosciences, for his leadership and support. Our former chair, Lynn May, especially for building up the department and hiring some fantastic faculty over the past few years. And I'm also incredibly grateful to Dr. Lynn Landmesser, who was instrumental in helping my lab set up some critical experiments to test respiratory circuit function. I believe that science can only thrive in a collaborative and supportive environment. And I feel incredibly lucky to have some really great colleagues and co-workers, both within the neurosciences department and also throughout the medical school. And I especially want to thank the Breuer, Schaefer, and Miranda labs, with which my lab has had many fruitful interactions and collaborations over the years. None of this work would have been possible without the fantastic students in my lab. You guys are really the heart and soul of the scientific endeavor, and I've been incredibly lucky to have fantastic students, Alicia, Rites, Matt, Minchin, and Raquel. And I think it's really a testament to the commitment of the medical school to graduate education that we do have such fantastic students in our program. Lastly, I would like to thank my parents, Kostas and Irini. Jonas Salk once said that good parents give their children roots and wings. And so I'm incredibly grateful to my parents for giving me both and for letting me choose my own path. My life has been made infinitely better by having my sister Anna, who's always been my partner in crime, but also an incredibly strong woman who I can always look up to. And of course, I would again like to thank Dan for his generosity, and I'm very excited and I look forward to all the exciting science we get to do in the next few years. And thank you all.
So Dr. Philippidou, that was remarkable, and you've outdone our expectations. And as I said at the beginning of my remarks, nothing is more exciting for a dean than to bestow an honor onto our brightest stars. And you've set a new standard, because now you're asking the next professorship to ask a 2,400-year-old question and solve it. We'll keep that in mind. So with that, it is in fact time to honor you, but you can sit in the chair as the Weidenthal family professorship in career development, and we look forward to a long career that is incredibly well developed. So congratulations.